So today's lecture is on threading. So what really is threading? So let's take an example like the human body, for instance. So the human body can do things concurrently, multiple things concurrently. So just think about it. As you're sitting here, you're breathing, your blood is circulating, your heart is pumping, your stomach is digesting food. And so it's doing all of these things at the exact same time. It's doing them concurrently. Well, a computer can also do things concurrently and can do these things all at the exact same time. And that's where multi-threading comes in. And so with today's computers, they either have multiple processors or they generally have multiple cores on a single processor. Now, because they have basically multiple brains within the computer, each core is can have a single thread of processing. So for instance, if you have a 4-core machine, you could have 4 things going at the exact same time. You could do 4 types of processing at the exact same time. And so in your program, you could create 4 threads and they could all operate at the exact same time doing their own processing. So that's what the idea of threading really is. And so we've been working with threading all along with, for instance, the garbage collector. And so the garbage collector runs on its own little thread. And so that's why you won't really notice it running, is because it just sort of starts up a new thread behind the scenes and then collects memory. In our code, anytime you want to deal with threading, you have to use the using system.threading namespace. And so this is going to contain the things that we're going to need to work with threads. Now we've already worked with the thread.sleep method, if you remember, in the dice rolling game. And so we had to include that system.threading, and we talked about why it was actually a bad way to lock up the UI, but it worked for our purposes to simulate the dice rolling. Well, now we're going to be talking about the correct way to actually use multi-threaded applications. So let's talk about the syntax of threads. So when you create a thread method, so think of it this way: a thread is just a method of execution. So you can define as many threads as you want, and then you just say, hey thread, you're going to point to this method when I start you. So if you just think of a thread as a method, it's really easy to understand. And so think of 4 different methods all running at the exact same time. That's all you're really doing. You instantiate 4 different threads using the thread class. You point each of those thread classes to a particular method, and then you just tell each thread to start. And when it says start, all it does is calls those methods that you've assigned to each thread. And so those threads can all now start executing at the exact same time. So a question sometimes I get is the difference between a process and a thread. So if I were to open up the task manager here and take a look at performance, for instance, and let's change this graph to logical processors. And so you can see this particular computer has 4 logical processors. And so what that means is if you want to, you can have 4 threads running at the exact same time because this is a 4-core machine. Now a given process, something like Visual Studio for instance, can have as many threads executing as it wants. So a given process here can have lots of threads executing within it. So we can actually take a look, and you can't even remember how to do it now, but you can bring up different columns to figure out, how many threads for a given application are running. So a process can have lots of threads within that process. So when you create an application like tic-tac-toe, if you wanted, you could create as many threads as you want within that process per se. So once we start a thread using the thread class, if you ever want in your main program, let's say like let's for example say we're generating a report for the user, and they click a button, and this, we know we're gonna have to go out to a database. We're gonna have to do a bunch of processing on this data, and it's gonna take, let's say, 20 seconds to generate this report. So what we don't want to do is generate all this report data on the UI thread. what we want to do is, instead of doing it on the UI thread where all of our button clicks, our mouse moves, all of the form interaction is being done, we want to instantiate that on a separate thread. So that way what we can do is we can say, okay, the user has clicked some button on our UI here that said, start processing. And then what we can do is we can then lock down our UI, say, hey, we're processing this. We can give them status updates. Hey, we're 20% done generating the port, 50% done generating the port. And what we could do is we could also have a cancel button. So let's say the user noticed that they entered the wrong date range for this report. So what we could do is we can have this cancel button so that our main form that instantiates our thread has the ability to tell that thread to abort. And so you're able to actually stop and kill threads that are executing. And now when you call the abort method, wherever your thread is currently executing, so again, just remember in this, all you're doing is calling a method. So let's say you're on line 10 of this method. Right when you call this abort method from your main UI here, when you do that, it's going to raise a thread abort exception. So just understand that you're going to need to handle that exception properly within your thread method, that you may need a way of doing that. Or another way to do it is, let's say you have a long-running loop within your other code, your thread code. You could have a Boolean check every time through the loop that your UI just puts in there that just, hey, the user has canceled me, so that it just exits out normally and just finishes its processing. Then you know the thread has stopped executing. Now, we've already worked with the thread class a little bit, so we can just type thread dot, and we can see some of the static methods that we can work with. And so, the one that we've already worked with is thread.sleep. Now, whenever you call thread.sleep, it puts whatever current thread we're in to sleep. So if I do it here, it's going to actually put the UI thread to sleep, which you would pretty much never want to do. You would use this, in your other methods, your other executing threads, never on your UI. So you can also do things like get the current thread. So if you need to get information within this method about what the current thread's information is, like name, or you want to be able to board it, things like that, you can use thread.currentThread. Also, when you instantiate a thread, let's just say thread, my thread, it's a new thread. I say my thread dot. There's all kinds of different properties we can access. For here, it says here's the abort method I was just talking about. So as this thread is executing, if you say thread.abort here, that'll stop the execution of the thread. We can get various things. We can see if it's alive. Talk about Jim getting priority is another good one. So thread priority you can set, so if this is a very important thread and you want it to run above all of the processes on the computer, you could set it to highest. The default is normal, and generally it's recommended that you always leave it on normal unless you have a very, very good reason to change it to one of these other levels. It can just kind of bog down Windows, or it can, for instance, if you do it at the lowest, who knows when it'll get the CPU. And if you want it the highest, again, you really need to know what you're doing here and why you're doing it. If it's really that important, do you want to set it to the highest? And then once we've set it to a method, and we'll take a look at some examples in just a second, you can always start the thread right here. You can even pause the thread by clicking suspend, but thread is how you would actually just say, hey, okay, go ahead and run this thread now. We'll take a look at how you actually point to a method. So what we're going to do is I'm going to jump over to an example from your book that I've given you on Canvas, this 15.3 thread tester. And so what this is going to do is they've got this message printer class. So always with your threads, you're going to want to put the method in some other class. You're not going to want, it just gets confusing if you put this print method, for instance. If you had just put that within your UI, it gets a little confusing that within your UI you have separate threads running inside of it. So generally you'll create some other class that will hold these thread methods. So you'll notice this class looks like just any other class we've created. There's not really anything special about it to say this method is going to be running on a separate thread. But you do need to be careful about anytime you're sharing data, and we'll take a look at a book example in just a second what that means. So we've got this message printer class, and here's the constructor for it. And what it does is when it creates this class, it just creates some random sleep time between 0 and 5 seconds every time you create a message printer class. And then within that, here we're just saying get the current thread's information. So this is how we can get, for instance, the thread name. And you notice down here, that's what they're doing. They're just outputting, hey, this current thread. And so the whole purpose of this print method is, again, this print method is going to be called multiple times, actually 3 times on 3 separate threads. And so 3 times in memory, you can think of 3 execution threads in memory. All of them just happen to be executing this print method. And so all it does is it comes in here, prints a message out to the console saying it's going to sleep for so many seconds, which happens to be this random time. So it could be the first thread, let's say, goes to sleep at 1 second. So it'll say, hey, we're going to sleep for 1 second. Puts this sleep to 1 second, and then it says, hey, we've woken up. Maybe the second thread, this random time was 3 seconds. So it comes in here, says thread 2 is going to sleep for 3 seconds. It sleeps for 3 seconds, and then it wakes back up. So it's just showing you the randomness, and it's showing you how the 3 threads are executing at the exact same time. And this is just a way of pretending to do some work here. So anytime you're seeing the thread.sleep in my examples or the book examples, this is just simulating real work. So this is going out to the database and doing a long running query that takes 5, 10, 30 seconds. Something you would never want to do on the UI thread, because yeah, maybe 99% of the time that particular SQL statement executes in like 10 milliseconds. So you think to yourself, it's never going to lock up the UI. The user is never even going to see a hiccup. However, let's say your database is down, which happens quite often in the real world. If your database is down and you try to connect to it and execute this SQL statement, it's going to lock up your entire user interface until that SQL statement finally times out, and then it'll give execution back to your UI thread. So even if you think your SQL statements are really fast, or whatever processing you think is going to be really fast, if it's non-deterministic, like opening up a file, going to the network, a database, or any complex processing, I would recommend always putting it on a separate thread and always doing as little processing as you can behind your actual UI. And that kind of goes back to what I've said when you're abstracting your data out into business logic classes, is all that complex logic should already be in these business logic classes, where your UI should be doing just things like updating the UI and displaying data and things like that. So it should be kind of dumb, where again the complex processing should be done in a separate class that you could run these methods on a separate thread if you set them up properly. So here we go. We instantiate 3 message printer classes, and then each one we set to a different thread method. And so to instantiate a thread, we say thread new thread. Then when we do this, we have to say, we pass in the constructor here, what's called this thread start class, or sorry, delegate. And remember, what does a delegate do? It just simply holds the way of pointing to a method. That's all a delegate does. It's just a variable that points to a method. And so all it does is we instantiate this delegate, and we say, hey, this delegate points to this particular method. Print1 dot, printer 2 dot print, printer 3 dot print. So we've instantiated this class 3 times, and we've pointed to each different thread to the print method of that particular class. And then we come down here, and then we just start all 3 of the threads, and then we say threads are started. Now let's go ahead and say console.read. That way it'll pause for us. So when we run this application, we can see it's going to pop up. It's going to tell us, they're going to sleep for various times. Then we're going to see them waking up, based on, the lowest sleep time, etc., etc. So it's just showing you that all of those particular threads were executing at the exact same time using the thread class. So a big problem comes in when you're trying to synchronize data amongst multiple threads. So what does that mean? It means that 2 threads are working with the same shared piece of data. So just imagine 2 methods and 2 separate threads executing along, and both of these threads need to access some shared piece of information. There's some object or some integer that both of these threads have to access. And let's say both of them need to read and write this same piece of shared data. Now, one thing I would always recommend, that if it's possible, do not share data between threads. It just creates headaches. Now, this isn't always possible. So sometimes it's just the way your application works, and that's what you need to do. So if that's the case, then you need to be very, very careful and try to work with that up front in designing your program. And so it's just sharing data amongst multiple threads is just very error prone. So let's take a look at an example from the book, how not to do things. So what we've got here in this figure 14.4 is this example program is going to show us a problem with how to synchronize data. And so what we want to look at here is we've got this interface called buffer. They've kind of made this a little bit more complex, I think, than they even needed to. But they've got this interface called buffer. All it is, it just says, hey, you need to have a buffer if your class implements this. So let's take a look at this unsynchronized buffer. The thing that you really need to understand about this unsynchronized buffer class is that within it, there is an integer called buffer, and this integer is going to be shared amongst two threads. So that's really all you need to know about this unsynchronized buffer class. Just remember, unsynchronized buffer has a shared integer variable called buffer that's going to be shared between both a producer and a consumer loop. And so the purpose of this particular program, if we come over here, what they're going to do is they're going to instantiate that unsynchronized buffer. So remember, this shared variable, all it is a shared integer. That's it. Then what they do is they create a producer class and a consumer class, which we'll look at in a second, and you can see they pass in this shared piece of data. So both of them are pointing to this same piece of shared data. So when one axis, so let's say the producer produces a value into this integer like 5, the consumer, when it reads the shared variable, would read 5. They're both producing and consuming to the same shared integer value. Then what they do is they create two threads here. One's the producer thread, one's the consumer thread. And then they both call a produce method, and the consumer calls a consume method, and then both of these start at the exact same time. And so what this program is showing you is that the producer is running and the consumer are running both at the exact same time, and the producer is writing data to that integer, and the consumer is trying to consume that data. Now the purpose of this particular program is that for every value the producer produces, the consumer needs to consume that value. So what shouldn't happen is, let's say the producer produces the number 5, the consumer should then read the number 5. Producer, produces the value 7, the consumer should read the value 7, so that you never miss a value. What you don't want to happen is a producer produces 3, producer produces 6, so the consumer then reads 6, and it lost that value 3. You don't want to lose any values. And so this program is going to show you the problem with sharing data between multiple threads. So let's take a look now at the consumer class, what it's doing. So again, we just pass in that shared buffer here. Now in this consume method, which will be run on a separate thread, all it does is it just has a for loop that we can see here runs 10 times. Now each time through the loop, it pretends to do some work. So it goes to sleep between 1 and 3 seconds. Then what it does is it tries to consume the value in that buffer. So it just tries to read the integer. And what it does is it just keeps adding that integer to this sum value. And then we would know that it read correctly if we ended up getting 1 plus 2, 2 plus 2, 3 plus, and then we just added, 1 plus 2, 2 plus 3, 3, and we just kept going all the way on. So each counter here should be added together. And that's how we know if we get the correct sum, we know that every value has been read. And the producer, it reads in the same shared buffer. It has a for loop that each time through its loop, it also sleeps between a random time between 1 and 3 seconds. And then it tries to produce a value in here. So this is where the problem comes in. So because these are randomly sleeping for different times, both the produce and consumer loop, we don't know how long it takes. We don't know this pretending we're going out to the database, and it may take 3 seconds to fill up this buffer. It may take 2 seconds, it may take 1 second. However, every time it produces, we don't want to lose a value via the consumer. So let's go ahead and run this, and let's take a look at what happens. And it's actually going to run differently every single time we run this application. What in the world happened there? Let me shut that down, run this again. I won't touch it this time. And so you can see producer writes 1, consumer reads 1. Now here we go. We had the consumer read 3 times in a row, then the producer wrote, consumer reading 3 times in a row. Now here we go. Here's a lost value. Producer wrote 3 and then 4, and the consumer read 4. So we lost this value 3 here. So this total is not going to be correct. So let's take a look now at what it takes in order to synchronize this data. And it could be a little bit complex, and it takes some time to get your head around it. But the idea being is that we've got this shared buffer, and anytime we want to use this shared buffer, we sort of need to lock it down. and we need to say I'm using this shared buffer. No one else can access it. No one else can read or write to it while I'm using it. So we need a way of restricting access. So what's going to happen in this example is the consumer is going to lock down that shared object and said, I have control of it now. I'm going to write a value. And then it's going to release this lock, and then it's going to go on. The producer is going to say, okay, I've now locked this value, so I can produce a value into it. Now I've released the lock, and then the consumer can come in and read that value, and it will lock it and read it. The problem comes in when, let's say, the producer produces a value, so it locks it down, produces a value 3, and then it releases the lock. Then the consumer comes in and it locks it and it reads this value. Great. Now let's say that the producer is sleeping too long, so the consumer wakes up again, so it's already read a value, so there's no new value to be read. It wakes up, it locks this buffer, and it tries to read the same value. So it recognizes that, hey, no new value is in here. So what happens is the consumer says, hey, I'm going to go to sleep, and whoever is producing a value, please wake me up and tell me to wake up that a new value is going to be produced. And so what happens is the producer comes in, it grabs the lock, produces a value, and then it actually sends a signal to the consumer that says, hey, you can now wake up and consume the new value. As soon as I release the lock, it releases the lock. The consumer now is sort of, pulsed. It wakes up and it can consume the value. So it gets a little complicated when you never want to lose a value. So this interface is exactly the same. This synchronized buffer is a little bit different, and that's where the magic happens. But I want to show you that the consumer here is exactly the same. So notice no code is changed in this thread. It just sleeps for a random amount of time, updates the buffer, or consumes the value from the buffer, and the producer does the exact same thing, except it randomly puts a new value in here at a certain amount of time. We come over here to the actual code. You can see that they're sharing the buffers, and they're starting the threads exactly like the other program. So all of the sharing complex code is happening over here in our new synchronized buffer. And so here's that same shared buffer. Now what they've done is they've created this occupied buffer count. Now why in the world they chose to do it with an integer versus a boolean is beyond me, but they did. And so occupied buffer count is just telling you whether or not there's a new value in this buffer. So it just says, 0 means no new data to read, and a 1 means there is data to read. Again, they could have used a boolean value. They chose to do an integer here. So first, let's take a look. Now we've got two properties. We've got our get, and we've got our set inside. Sorry, we've got one property with a get and a set inside of it. So let's take a look at the set first. So we come in here. Now what you'll notice is happening is they're using this monitor class. And so what that is saying is that, now mind you, this is the set, so this is the producer. So the producer, when it comes in here, this is its way of saying, hey, whoever is calling this object, it is now locked down for whichever thread is entering it here. So the whole rest of this code can only be executed, or this whole object will always be locked down inside of here. If you look inside the get, there's also a monitor.enter. So what happens here is that, let's say the producer is producing a value, so it has locked down this object, so this is the object that you're locking down. If the consumer comes in here and tries to execute this line of statement, this code, it can't do it because the producer already has a lock on it. So it'll wait right here until the producer releases the lock, then it can continue executing on. So the producer locks down this object, and then it comes in here and it says, okay, do I even have an empty buffer? So it wants to produce a value, however, it can't do it if the consumer has not read that value yet. Remember, we don't ever want to lose a value. So what we have to do is it says, hey, the occupied buffer count, if it's 1, then that means I can't do any work. And so what it does in that is it says, I'm going to wait right here. And so it actually goes to sleep right here, and this releases the lock on this object. That's what this statement does here. And so it just sits here, it literally just pauses execution, but it releases the lock, and that way when the consumer comes in, it can then gain access to that lock, and then it goes on, and then when it releases the lock, it can pulse this thread and it'll wake up and continue executing on. And this will, hopefully this will make sense as we go through this a few times. So now let's pretend that this is actually equal to 0. So it skips over this code. So the buffer's empty. So what we do now is we go ahead and we just set the buffer to whatever value was passed in, right? Because that we are setting a property here. Then what we do is we say, okay, if the consumer was hit that other lock statement and it's waiting there, we pulse it and say, hey, we're about, get ready to execute because I'm about to release the lock. And then when we actually do the monitor.exit statement, that releases the lock, and the consumer can now continue executing on from this statement here if it was locked down. So that's how the producer works. It comes in here, it acquires a lock, determines if the buffer is empty. If it's not empty, then it waits right here. It just pauses execution, releases the lock until the consumer pulses it and releases the lock. Then it would wake up. When it can produce a value, it goes ahead and sets the buffer value, tells other threads to wake up that's waiting on it, and then it releases the lock. Now if we take a look at the get here, it comes in and says, okay, I'm trying to consume a value, so I need to lock it down, this entire object, so that another thread can't produce or consume the same value. So it comes in here and says, hey, is this occupied buffer count set to 0? If it is, that means there's no value that I need to read. So if there is no value, I need to wait right here. Just like the producer needed to wait, the consumer, there's no new value to consume, so it just pauses execution right here, releases the lock, and now it just sits here until the producer produces a new value, and then the producer itself does this monitor.pulse statement. That's how it tells it to wake up, and then the lock gets released and it wakes up and continues executing on. So let's say the buffer count is equal to 1, so there is something in there. We decrease the buffer count, and then what we do is we have to do something a little bit tricky here. Now, we're actually trying to get this value. Now the problem with this is okay, so we tell the other thread to, hey, get ready to execute. And so we do this monitor.pulse. But you'll notice what they actually do is they actually get a copy of that buffer value. So they read the buffer value, release the lock, and then do this return statement of the buffer copy. Because remember, the return statement always has to be the very last statement. So you can't return this value and then release the lock. So you couldn't say return just buffer because you'd never release the lock. So what we have to do is we have to say, okay, get a copy of the buffer, then release the lock, then return the buffer copy. Now, why do we have to do this? It's a little bit tricky, but think about what could actually happen in computer time. Let's say the CPU is going along. Now this thread is the only executing thread. So let's pretend we did not do this statement. So let's say we hit this statement and we release the lock on our thread. Then we come down, and before we execute this statement here, the CPU actually gives time to this other thread down here. So this thread stops executing, this thread gets the CPU time, and it actually sets this buffer value. Then this thread gets CPU time, and so it actually returns this new overwritten value. So you actually missed the buffer value. And it's really tricky. You have to kind of think through this. This is one of the complexities of sharing data between multiple threads. So now if we just grab a copy of this buffer, so we make a local copy of this integer, then we release the thread, it doesn't matter what happens to the buffer at that point because we're just returning the original copy of the buffer. So now we come to the synchronized buffer, everything executes the exact same way. So now when we run it, what you'll see is that it's going to go through and it's always going to produce and consume a value. Now here you'll notice that the consumer tried to read and it tried to read again, but it couldn't. So it actually said, hey, I need to wait until the producer produces a value. So you can always see it goes back and forth correctly, getting us the total number 55, which is 1 plus 2 plus 3 plus 4 all the way to 10. And so you can see there's multiple times now, because it was random amount of time, that the consumer tried to read again. It says, hey, I need to wait longer until the producer writes. Then it woke up the consumer thread, then it read the correct value. So just be really careful whenever you're trying to share data amongst multiple threads. And if you can, just don't do it. So the next thing I want to take a quick look at is some example programs now that I've given you. So what I'm going to do here is I'm going to show you some different ways that you can work with threading, especially with your user interface. So the first example here is going to show you the thread class that we just learned about and how you can start a new thread. You start executing this other method, and then you need a way of notifying the UI, hey, I'm done executing. So you'll give the user a message. This thread's done all the processing. Now we can update the UI. This other one is going to show you an example of what's called the background worker. And so you'll notice the background worker actually exists in our toolbox here under components. You can see here's a background worker that you can drag and drop over here, or we can instantiate it behind the scenes. With this Windows Forms example, I'm going to drag and drop it on here and show you how to use it. In the WPF example I'm about to go over, I'll actually show you how you instantiate that behind the scenes and work with it. And again, this is a class that Microsoft's written in order to, and it encapsulates all the threading complexities for you with starting up what they call a background worker, which is actually just a new thread. And then they take care of all the tough communication between this background thread and your user interface and error handling. So it's really nice to use this background worker when you're trying to do something like this, where you start something that takes a long time to process, you need to update the UI on occasion, and then when it's all done you need to display all the data or do some extra processing when you're all done back on the UI. So first let's take a look at starting a new thread here. So now when we're starting a new thread, the very first thing we're going to have to do is create a delegate. So when we create this delegate, make some more room here. What we're going to do is we're going to create a delegate that called display message delegate. So what this is going to do is this is going to hold a reference to a method that's going to get called when we're all done with the work on our thread. So remember, in a background thread, these separate threads we're going to create, you can never reference a UI object. So what I mean by that is over here on my UI, I've got this little hidden label right here. Now this label has been created by the UI thread. So any separate threads that I create when I click the Start Thread button cannot access that label. You cannot use it, and you will get an exception if you try to access it. So what you have to do is you have to use this delegate, and your thread says, okay, I've got some work for you to do, UI. Here's a method I want you to call on the UI thread. So it's sort of a way of saying, I'm done processing, now go ahead and execute this method on the UI thread so you can alert the user that you're done processing. So let's come down here, and the first thing we're going to do is when they click this button here, we're going to give the user a message to begin processing. Hey, we've started. Now we can do this statement because it's behind the user interface. This method is executing on the UI thread. So now what we want to do is we want to start a new thread. So to start a new thread, we use the thread class. We'll call this my thread equals a new thread. Now here we have to instantiate a new thread start delegate, and we point to the method, for instance my thread method here that I've already created down below. So this is the method that will get started, which happens to be right here when I say my thread dot start. So we've told the user interface, the user, hey, we're going to begin processing. Instantiate the thread, start the thread. Now this particular method, it does this statement which starts executing this method here, and then the rest of this method. So let's just pretend there was a whole bunch of code after this thread. It would execute this thread, and all the rest of the code here and the code here would start executing at the exact same time. Then once this bracket gets hit here, it sort of releases that sort of lock on the user interface, how we've seen it sort of pause, and it comes back and it starts handling events again just fine. So by doing this now, all that heavy processing is done on our separate behind the scenes thread. And so it has given the user the ability to do other things with the user interface. So now what we're going to do is we're actually going to go ahead and put our thread to sleep for 3 seconds. This simulates going to the database or something to that nature. Now what I'm showing you here is that you cannot access any UI control from a background thread. So if you try to do this, an exception will get thrown because this label belongs to the UI thread and you cannot access it from a separate thread. So now what we want to do is, let's say we're all done processing. So we've gone to the database, we've pulled all this data down, and so now what we want to do is tell the user interface that we're done. So what you'll notice down here is I've created this method called display message that all it does is says, hey, we're done processing. Now what this also could do is in here we could fill up some piece of data inside this class that says, like, maybe it's a big string that says sReport data, and then down here this could actually then display that report data. And so let's say we did all this work, and so now we want to tell the UI, hey, we've got some work you need to go do. And so we need to invoke this other method on the UI thread. So this will actually run on the UI thread so we can access that label. So in order to tell the UI to do some work for us, what you have to do is you need to get some UI element like LBL message, because what we need to do is we need to get a handle to this invoke method. I also could have done something like this dot invoke if I wanted to. So any UI object you can get handle to this invoke method, and it's just a way of calling invoke is just a way of getting a handle to the UI or sending work to the UI. And so what I'm going to do now is I'm going to instantiate, you can see it takes a delegate passed into it. So I just happen to have created that display message delegate. Then I'm going to pass into this display message. And so what this is going to do, oops, put the wrong one in there, is this is going to say pass some work to the user interface, and this is the work I want done on the user interface. And so it then comes down here and it starts executing this code here. Now there is two methods you need to be aware of with invoke. There's invoke and begin invoke. And so let's say we have some other lines of code down here. We've got this, we've got a for statement. Let's say we have 50 other lines of code after these statements here. So let's comment this one out. When we say, hey, I've got some work for you to do, UI, and you call the invoke method and tell it to do this work, what that actually does is it actually pauses this thread here. So it'll actually just, you'll see it if you debug it. It'll come to this line of code and it will not continue executing on until this method here is completed processing. So if this takes 3 seconds, let's say it's going to come here, execute this line of code, this line of code, this line of code. It's going to come to here and it's going to call display message, but this thread is going to pause if this takes 3 seconds before it continues executing on with its code. Now sometimes that's what you want. Now what maybe sometimes you want is just to send some work to the UI, and then you have other processing you need to get to immediately. So you can use the begin invoke. So this statement says, hey UI, I need you to go do this work, and I know you'll get done with it, and then I'm going to immediately continue executing on. So that's the difference between invoke and begin invoke. Let's go ahead and drop this down. So now when we run our program, it's going to start a new thread. This thread will go to sleep for 3 seconds. Then when it wakes back up, it's going to, or when it's done processing, it's going to display this message and message because we called it right here. Now this thread will just execute end normally because it'll execute this line of code, and then here, then the thread just destroys itself. It's gone because it completed all of its work. Now the second example I want to go over is this background worker. So the background class is really nice. What it does is it encapsulates all of that thread logic that we just saw over here of having to start threads, communicating with the UI, things like that. And also what would happen error-wise if an error happens in this processing over here. So let me come over here to my properties and I click on this background worker. And what's kind of cool about the background worker is you can set the name here. There's a property called worker reports progress, and what this allows you to do is that as this background worker is executing, and remember it's just a separate thread, as it's is as it's executing, you can actually report progress to the user interface. Hey, I'm 10% done, I'm 30% done. And you can actually send data along with that update also. Now what I've done is on the events here, there's 3 events you can handle: the do work, progress changed, and run worker completed. Do work, this is your background thread. So when you say, start this background worker, this method here is what happens on the separate thread. Everything that happens inside this method here happens as the separate thread, just like we did thread.start. That's what do work is. Progress changed now. Inside do work, you can say, hey, progress has changed, which what it does is it actually calls this method here on the user interface thread, which is really nice. So it's really easy to communicate between the background thread and this user interface thread. Now run worker completed, this automatically gets called for you as soon as do work stops executing, whether an exception is thrown or it continues, it just exits normally with all of its work. It automatically calls this run worker completed. So because it does that, you don't have to worry about doing this sort of nonsense with the begin invoke. It just calls the UI automatically for you, called run worker completed. So let's come down here. Let me scroll down, open up example number 2. And so now that we've said all those things, what we can do is we can go ahead and just start our background worker. So when you click that button, we want to do 2 things. We want to tell the worker that you've started, just like we did on our other thread. And then what we're going to do is we're going to say our background worker 1, run worker async. This is exactly the same as saying thread.start. They just created a method called run worker async that starts your background worker. Now when you call run worker async, because we'd wired up this method to do work, this is where all of the work happens behind the scenes. So now what I'm going to do is I'm going to put some code in here that just acts like it's doing some work. So what's actually going on here is it says, okay, this separate thread, go to sleep for a second. When it wakes up, I say background worker 1, report progress, and here is the progress I want you to report. Now what's cool about this report progress method is that not only can you return an integer as the first parameter, you can actually return an object of user state in here. So I'm returning the progress 25, 50, 75, 100 for this initial parameter here, but because you can also return an object, I could return maybe an employee object in here if I wanted to. And so I could return that entire object of data to the user interface. Or maybe I return a class worth of data of your report processing. And so you just sort of slowly increment what data is displayed on the user interface as you do this complex processing. So then I go to sleep for 2 seconds. Then I report progress. Now every time I call this method here, because I wired it up on the UI there, this method gets called. Now this method is on the user interface thread. And so what we can do is, you can notice here's this object sender. So we can say e.progress percentage, and that's this value here. And if we want to, there's also this user state, and that's that object I could also pass back, but we've decided not to use that. So this is just, every time this wakes up, it's going to execute on the UI thread and report that percentage that we're done. So this is a really nice way that, if you got something that's taking 30 seconds, a minute to run, that you're constantly telling the user, hey, I'm still working here, and you can update some sort of status bar or give the user a percentage of the way done. And it's just a nice way to tell the user, hey, I've got like 30 seconds to go here, don't worry, the program is still running. I mean, honestly, how many times have you ran an application, you've clicked a button, and the whole thing just locked up on you, and you had no idea if the program crashed until it just magically started working again, right, and it displayed all of your data. So think about that type of user experience you received from that application. And always think about that when you're creating your applications. Your UI should never lock up. So anything like that you always want to do on a separate thread. Now after we execute this last line of code and it exits normally from this background worker, you'll notice down here that it just says run worker completed. Now on the run worker completed method, it's on the UI thread automatically when this gets called, and so we can just update that label. So it's 2 ways that now we've looked at threading. I generally like to use the background worker when I'm doing this sort of get a bunch of data. It's going to take a while, then I'm going to update the UI with it. But you can see we've started the thread, and see how my UI is not locked up. Start background worker, it's not locked up, but you can see now I'm telling the user, hey, 25, 50%. So the user sort of has a way of anticipating how long it's going to take, and then it's finished, and we update the user interface. So now that's Windows Forms. Let's take a look now at WPF threading. And so what we're going to do now is we're going to have what looks like the exact same example here with threading and background workers. So the first thing we're going to do here is we're going to create that same delegate, because we know in our thread that we're going to have to update or send some data to work on the user interface thread. Now what this example also is going to do is it's going to instantiate a background worker in code. So before we use the UI to set it all up, here we're actually going to instantiate it. And so now what we're going to do is we're going to come in here, instantiate our background worker. Then what we want to set is all those same properties we saw on the user interface before. So the first one was worker reports progress. So we're going to set this to true so we can actually report the progress as we go along. The next one is do work. And so you'll notice I can say plus equals and it's going to say background worker do work. Now I did this already for us. And so you'll notice I've got this background worker do work one for us already. So what I'm going to do is I'm going to go ahead and just delete this. And I'm going to copy and paste some code in here. Just so we get everything right. And so you'll notice that I've set my background worker, I've set it to true, I've set my do work to this particular method, I've set my progress change to this method, which all correspond to these methods down here that you'll notice. So you can see I'm saying, okay, here's my do work, my background worker one do work, so it's going to call this method on the separate thread. This is progress change, so it's going to call this one every time the do work reports progress, and then run worker completed will call when the do work is finished. So first let's take a look at our threading example. So we come in here and we're going to start a new thread for us. So all we have to do is, say my thread equals a new thread. So we'll just paste the code in. So you'll notice thread, my thread equals new thread. Hey, call this method on a separate thread. So it comes down here. Again, I'm telling you that you cannot access a UI element in a separate thread. And you couldn't do this also in the do work method down below on the background worker. You cannot access a UI element in any other thread besides the UI thread. And then here I'm calling begin invoke. Now this is a little bit different than the Windows Forms application. The Windows Forms we need to say this dot invoke or label dot invoke. Well in WPF the way to get access to the UI we always have to use this dispatcher class. The dispatcher is in charge of all events that will go on the UI. So what we say is this dot dispatcher dot begin invoke or this dot dispatcher dot invoke. Exactly the same that we did on Windows Forms. There's an invoke and a begin invoke. It's just how you get to these methods is a teeny bit different. And then we just pass in our display message, which just says, hey, we're done processing. When we come down to our background worker, so now we click it to start our background worker. So all we have to do is say background worker dot run worker async. So we just start our background worker, which calls our do work method here. And so you'll notice I've done something a little bit different in this example where I do all the same where I just go to sleep and then report processing. However, when it's all done, let's go ahead and throw an exception. So this is going to give us a divide by zero exception and it's going to throw an exception, but you'll notice there's no try catch blocks in here. And I've done this on purpose. And you don't need to put try catch blocks on here because any exception that gets thrown inside do work automatically calls run worker completed. But let's first take a look at progress changed, which is exactly the same as before. It just updates that UI label. So now in run worker completed, what we can do is in that E that gets passed in, so we say E dot, and so not only can we get the result of what's happened here, what we can get is this error code. And so this tells us whether or not an exception occurred in our run worker completed. So when this executes, it's actually going to throw an exception and set this property to true. But when this exception gets thrown, all it does is it doesn't crash our program, it just calls this method, then executes this line of code, and then we check, hey, is there actually an error? If there was, go ahead and display it. So let me uncomment or comment this back up, and let's execute it normally. So we run our code. We come in here, we start our thread. You see, it begins, it does this. I can even start this one at the exact same time because I'm running on separate threads. So it comes in here, percent completed, 100% you have finished. Now let's uncomment this again. Oops. Now we run it. And so now you'll notice that it's not going to crash our program because that thread actually handled the exception by itself. And then we checked for an error, and then we're going to, this just happens in the debugger, but you can go ahead and continue executing on. And so it comes in here and it says attempted to divide by 0, but you can see our program didn't crash. That was just the debugger. If you're running just the exe, it would not stop processing right there. But you can see it didn't crash our program, and we handled that exception and displayed it to the user just fine. So that's some examples of how you can do threading and use a background worker for threading. And it just really helps to enhance the user interface on the user's experience.